Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video for subject Electrical Circuits 1, code BEV 10303, and in this video, which is a part 3 video, we are going to continue our discussion on topics of chapter 3, which is circuit analysis. Okay, so let's move to the next slide on what are the contents that we are going to cover for today session. Okay, so for today we are going to see the analysis of the technique of what we call as a nodal analysis. Okay, so for nodal analysis, so usually the nodal analysis is used for analyzing circuits by using the node voltage as the circuit variable. Okay, so unlike the mesh analysis, for the mesh analysis, the analyzing circuit is based using on the mesh current, but here we are using the node voltage as the circuit variable. Okay, and then the important key idea here is we consider resistance is a passive element. So by using the passive sign convention, current must always flow from higher potential to the lower potential. Okay, so now we refer to this diagram, okay, where you have a resistor that considered as a passive element. So following the passive sign convention, the current I will be flowing from the higher potential to the lower potential. Okay, so it means that the current will be flow from the positive terminal to the negative terminal. Okay, so that's why in this case, I will be equal to the V higher minus V lower divided by R. So V higher minus V lower divided by the value of R. Okay, so for the nodal analysis, we apply KCL to find the unknown node voltage. Okay, unlike the mesh analysis that we learned in the previous video, for mesh analysis, if you still remember, we apply the KVL to find the unknown mesh current. Okay. Okay, now let's have a look at the following steps on how to determine the nodal voltage based on the nodal analysis. Okay, so consider this circuit. Okay, let's say you are given this kind of circuit. So step number 1, you need to select a node as a reference node, which is commonly known as a ground. So in this case, we assign the ground to this node. Okay, and then you need to assign the node voltage to the n-1 node. So in this case, how many n do you have? You have first node, second node, and then third node. So 3 minus 1 will be equal to 2. So you need to assign the 2 node voltage. So in this case, VA and VB. Alright. And then you need to assign the branch currents to each of the n-1 nodes. So you need to apply the branch currents at node A and node B. In this case, for the node A, you have IB1, and then you have I1 and I2. At node B, you have I2, I3, and IB2. Alright, so after that, step number 4, you need to apply the KCL to each of the n-1 nodes. So in this case, you need to apply KCL at node A and apply KCL at the node B. So you need to you need to use the Ohm's law to express the branch current in terms of the node voltage. So meaning that you need to come up with the equation IB1 will be equal to I2 plus I1. Then I2 will be equal to VA minus VB divided by R2. And then I1 will be equal to VA minus 0 divided by R1. Okay, so you need to apply the Ohm's law to express the branch currents, these branch currents, in terms of the node voltage. So finally, based on the application of the KCL to each of the n-1 nodes, you are going to get a set of simultaneous equation. Okay, so the number of sets depends on the number of the nodes. Okay, so and then after that, you need to solve the resulting n-1 simultaneous equation to get the node voltage. Okay, so in this case, you have a 1 and 2. So you are because of you apply the KCL at these 2 nodes, so you are getting 2 simultaneous equation. Okay, so let's say for example you have another circuit when you applying KCL at 3 different nodes. Okay, so you are getting 3 simultaneous equation. All right. Okay, so now let's have a look. So now let's have a look at the following example 3.5. So based on this circuit, so you need to write the matrix equation for the following circuit. Okay, so the step by step on how to solve the question. Step number 1, you need to label the nodes including the reference node. Okay, so in this case, here you have a ground, okay, and then you have a node A and node B. And then step number 2, we need to assign the node voltage and branch currents to the n-1 nodes. In this case, we have a 1 node, 2 node, and 3 node. So n-1 node will be equal to 2 nodes. Okay, so you need to assign the node voltage to the 2 nodes. So you have VA and VB. And then for the branch currents, we apply for the first node, you have a IB1. Here you have a I1, here you have a I2, and then branch current to the other nodes. Here you have a I2, here is I2, that's why here also I2. And then you have a current source, you have IB2, and then here is a I3. Okay, so for the step number 3, you need to apply KCL to each of the n-1 nodes. Okay, so we apply KCL at node A and apply KCL at node B. So first of all, we apply KCL at the node A. So in this case, the total of current that going into the node will be equal to the total current that going out from the node. So in this case, IB1 will be equal to I1 plus I2. Okay, and then once you apply the KCL, you need to use the Ohm's law to express the branch currents in terms of the node voltage. So how to apply the Ohm's law? So in this case, IB1 is a current source, so that's why you just copy the IB1. Okay, for I1 will be equal to VA minus 0 divided by R1. So that's why here you have VA over R1. Okay, ground node will be equal to 0. So that's why you can simply assume here VA minus ground is a 0. Okay, VA over R1 plus the current will be flow from the higher potential to the lower potential. So that's why VA minus VB divided by R2. Okay. Right, so this is considered as a equation number 1. Okay, next we apply the KCL at node B. So for node B, I2 plus IB2 will be equal to the I3. Okay, and then after that, you apply the Ohm's law to express the branch current in terms of the node voltage. So you have IB2 plus I2 will be equal to, so here I2 will be current through here will be equal to VA minus VB divided by R2. Okay, because current flow from the higher potential to the lower potential. So VA minus VB divided by R2. Okay, equal to I3. I3 will be equal to VB minus 0 divided by R3. So 0 can be further simplified, become VB divided by R3. So this equation we consider as a equation number 2. Okay. So next, we can simplify the equation number 1 and equation number 2. So based on the equation 1 from the previous slide, we can further simplify. Here you have VA over R1, here VA over R plus VA over R2. So this way here VA I factorize to the outside, multiply with 1 over R1 plus 1 over R2 minus. So here we have negative VB divided by R2. So here you have negative VB divided by R2. Okay. So for equation number 2, you have IB2 will be equal to, so we put VA first. So VA, negative VA divided by R2. So negative VA divided by R2 plus VB over R3 plus VB over R2. I can factorize VB to the outside. So plus VB multiply with 1 over R2 plus 1 over R3. Okay. And then finally, we can go to the step number 4 where we need to rewrite the equation in the matrix form. Okay. From the above equation. So we can consider here is the, according to the matrix, here is the A11, A12, A21 and A22. So here is the A11. Okay, A11 will be equal to 1 over R1 plus 1 over R2. Okay, so here is the one A12. A12 will be equal negative 1 over R2. Okay, for the A21, negative 1 over R2. And then for the A22 will be equal to 1 over R2 plus 1 over R3. Multiply with the two matrix which is VA and VB. Okay, equal to 1B1 and 1B2. Alright, so this is the final answer for the question. Okay, next we go to the example 3.6. So based on the given circuit, we need to find the V and I. Okay, so in this case, V is the voltage across 4 ohm. And I is the current flow through the 8 ohm. Okay, so we are going to solve this question by using the nodal analysis. Okay, so let's have a look at the following solution. So step number 1, as usual, you need to label the nodes including the reference node. So in this case, I will be labeling here node 1, node 2, and here is the node ground. Okay, and then after that, assign the node voltage and then the branch currents to the n-1 node. So in this case, I'm going to apply the I'm going to assign the node voltage to the node number 1 and node number 2. Okay, so for node number 1, so here is the V1. Okay, so the branch current is given by I1. So 2 ampere is a I1 equal to I2 and I3. Okay, and then for the node number 2, V2. So here I have I3 here. So that's why here also I3. And then I4, because we have a current source here, I4 and I5. Alright. And then after that, we go to the step number 3. We apply the KCL at each of the node. So in this case, KCL at the node 1, KCL at the node A is node 1 lah. Alright. So KCL at here is equal to I1 will be equal to I2 plus I3. And then after that, you need to use the Ohm's law to express the branch currents in terms of the node voltage. Alright. So in this case, I1 is equal to 2 ampere. Okay, so I2 will be equal to V1 minus 0 divided by 4. So V1 over 4 plus I3 will be equal to V1 minus V2 divided by 2. Okay, alright, and then after that we can further simplify the equation. So we can multiply here with 2 over 2 because we want to have a same denominator here. So we multiply with 2 over 2, so we get V1 over 4 plus 2V1 minus 2V2 divided by 4. Okay, and then after that, the 4 number, this 4 we can bring to here, so we get 8 will be equal to, so V1 plus 2V1 will be equal to 3V1 minus 2V2. Okay, so this is considered as a equation number 1. Okay, and then we just apply the KCL at the second node, which is node 2, or here I put it as a node B. Okay, here is a node 2. So here the KCL will be equal to I3 plus I4 will be equal to I5. Okay, so total of current that going into the node, which is I3, and I4 will be equal to total current of going out from the node, which is I5. Okay, and then after that, for I3 will be equal to V1 minus V2 divided by 2 plus I4 is 3. Okay, and then I5 will be equal to V2 minus 0 divided by 8. Okay, so that's why here you have V2 over 8. And then after that, we can further simplify this equation by making the denominator same. So here we can multiply this term with 4 divided by 4 because we want to get 8 here. Okay, and then here we multiply with 8 divided by 8. Okay, and then I have 4V1 minus 4V2 divided by 8 plus 24 divided by 8. So 24 divided by 8, you get back the 3 equal to V2 minus 8. Sorry, V2 divided by 8. Okay, and then after that, all this 8 number can be cancelled. So finally, I have 4V1. So minus 4 minus 1 will become equal to minus 5V2 equal to plus 24. You bring to this side, you get negative 24. Okay, so this is considered as a equation number 2. Next, we need to rewrite the equation in terms of the matrix form. So we rewrite in terms of this. And then after that, you just solve the equation number 1 and equation number 2. Or you can just solve the above matrix form using the calculator to get V1 will be equal to 12.57 volt and V2 will be equal to 14.86 volt. Okay, but the question are asking about the value of V and the value of I, right? So in this case, V will be equal to the V1. So V will be equal to V1. So in this case, V is 12.57 volt. And for the I will be equal to I5. Okay, I5 will be equal to I3 plus I4. Okay, and then I3 will be equal to V1 minus V2 divided by 2 plus I4 is 3. Okay, and then I can just substitute the value of V1 and V2 accordingly based on this. And then finally, I got I will be equal to 1.85 ampere. Okay. Okay, next we go to example 3.7. So based on the question, you need to calculate the node voltage for the following circuit. Okay, so based on this, you have one node and two nodes. Okay, so here you need to find the node voltage for this and this. Okay, so let's go to the solution. Okay, so the step number 1, you need to label the nodes including the reference node. So in this case, I have node 1 and node 2. Here is the ground. Okay, and then after that, step number 2, you need to assign the node voltage and then the branch currents. So here you have a V1, so and then the branch current will be equal to, here you have a current source, so that's why here is I1, here is I2, and here is I3. And then after that, for node number 2, you have a V2, so and then here you have I3, so that's why here I3. So here is current source I1, and here is another current source I5, here is the I4. Okay, and then after that, we go to the step number 3. You need to apply the KCL at each of the n-1 node. So you need to apply KCL for the node 1 and KCL for the node 2. So first of all, for the KCL at node number 1, so we have I1 will be equal to I2 plus I3. So in this case, I1 is 5. Okay, 5 will be equal to I2. I2 is V1 minus 0 divided by 2. So V1 divided by 2 plus V1 minus V2 divided by 4. Okay, V1 minus V2 divided by 4. And then after that, I want to further simplify my equation so that I can have the same denominator. Here I have 4. Here also I want to have 4. So I can multiply this term with 2 divided by 2. So 2V1 divided by 4 plus V1 minus V2 divided by 4. Okay, here is equal to 5. And then after that, 4, we bring to the here, you get 20. So 2V1 plus V1 is equal to 3V1 minus V2. Okay, so this is considered as equation number 1. And then we apply KCL at the second node. So KCL at node 2. So here you have I3 plus I5 will be equal to I1 plus I4. Okay, so total of current going in is I3 plus I5 equal to total of current that going out, I1 plus I4. Okay, and then in this case, I3 will be equal to, remember for for the current will be flow from the higher potential to the lower potential. So that's why you have V1 minus V2 divided by 4. Okay, V1 minus V2 divided by 4 plus I5. I5 is 10. Okay, and then I1 is 5. Okay, 5 here plus I4. I4 is V2 minus 0 divided by 6. So V2 divided by 6. Okay, and then after that, we can further simplify the equation so that we have the same denominator. Here you have 6, here you have 4, so you can make it 12. So here I multiply this term with 3 over 3, so that I got denominator become 12. So 3V1 minus 3V2 divided by 12. Here is 120 divided by 12, because 120 divided by 12 you get back 10. Okay, so it will equal to 60 divided by 12 equal to 5. Okay, plus here I can multiply this term with 2 over 2 to get the denominator become 12. So 2V2 divided by 12. Okay, and then after that, this 12 can be cancelled out. So finally, what I have is a 3V1. Okay, minus 3 minus 2 will be equal to negative 5V2 equal to 60 divided by 60 minus 120 will be equal to negative 60. Okay, so this is considered as equation number 2. Alright, and then after that, we can rewrite the equation in terms of the matrix form. So based on the previous equation, you have 3V1 minus V2 equal to 20, and then you have 3V1 minus 5V2 equal to negative 60. So that's why here you have 3, negative 1, 3, negative 1, and 3, negative 5. 3, negative 5 multiplied with V1, V2 equal to 20 and negative 60. Okay, and then after that, we can solve the equation number 1 and equation 2. So you can solve this using calculator, or you can just use a function matrix in your calculator to solve the matrix. So finally, you can get V1 will be equal to 13.33 volt, and V2 will be equal to 20 volt. Okay. Okay, so we go to the last example for this video, which is example 3.8. So based on the circuits given, you need to determine the voltage at the nodes. Okay, so in this case, you have node 1, node 2, and node 3. So which means that you need to find V1, V2, and V3. Bear in mind, when you have a 3 nodes, meaning that you are going to have 3 different simultaneous equation. Okay, so let's have let's have a look at the following step by step on how to solve that. First, you need to label the nodes, including the reference node. So in this step can be skipped because the question already give you the nodes 1, 2, and 3. And then you go to the next step. You need to assign the node voltage and then the branch current. Okay, so here we have V1. Okay, V1 you need to assign the branch current. So here you have a I1. Okay, I2 here is I3, and then for node 2, V2, and then you have I3 will be equal to I4 and I5, and then for the node 3 you have V3, and then here I5, here also I5, here is I1, here also I1, and then you have another source of current here is a I6. Okay. Alright, and then after that we go to the step number 3. We need to apply the KCL for each of the node. Apply KCL here, KCL here, and KCL here. Okay, we go one by one. KCL at the node 1. So for here you have current that going in is I2 will be equal to current that going out, which is I1 plus I3. I2 will be equal to I1 plus I3. And then I2 is equal to 3. So here is 3 equal to I1. Okay, I1 here. For current will be equal to the V higher minus V lower. Okay, so the current will be flow from the higher potential to the lower potential. So in this case, V1 minus V3 divided by 4. V1 minus V3 divided by 4 plus I3. I3 is here. I3 V1 minus V2 divided by 2. Okay, and then after that I can further simplify my equation so that I have the same denominator here. So here I have 4, here also I want to make it 4. So I can multiply this term with 2 divided by 2. So I can get here 2V1 minus 2V2 divided by 4. Okay, this 4 I can bring to this side, so become 12. So 3 multiplied by 4 is 12. Okay, so V1 plus 2V1 will be equal to 3V1. Okay, here minus 2V2, here is minus V3. Okay, so consider this is as an equation number 1. And then next we go to the node 2. We need to apply KCL at node 2. In this case, I3 will be equal to I4 plus I5. Okay, and then after that I3 will be equal to V1 minus V2 divided by 2. Okay, V1 minus V2 divided by 2. So for I4, V2 minus 0 divided by 4. So V2 divided by 4 plus here V2 minus V3 divided by 8. V2 minus V3 divided by 8. Okay, and then after that I can further simplify my equation so that we have a same denominator. Here we have 8, so here also we want to have 8, so I can multiply this term with 2 divided by 2. So I have 2V2 divided by 8. Here I want to make it 8 as well, so I can multiply this term with 4 divided by 4. So 4V1 minus 4V2 divided by 8. Okay, and then after that this 8 can be cancelled out. So finally I can have 4V1. Okay, so negative 4, negative 2, negative 1 become negative 7V2 plus here you bring to this side, you get plus V3 equal to 0. Okay, so this is considered as your equation number 2. Next, you need to apply KCL at the third node. Okay, so KCL at the node 3 will be equal to I5 plus I1 will be equal to I6. Okay, so in this case I5 will be equal to V2 minus V3 divided by 8. Okay, V2 minus V3 divided by 8 plus I1. I1 is V1 because the current will be flow from the higher potential to the lower potential. So that's why V1 minus V3 divided by 4. Okay, V1 minus V3 divided by 4 equal to I6. So in this case, I6 will be equal to the current source. So here is the current control current source. So the I6 will be equal to 2IX. Okay, right. So what is this IX actually? So IX is referring to here. Okay, Ix will be equal to I3. So in this case, Ix is equal to I3. And then I3 also will be equal to V1 minus V2 divided by 2. Okay. So remember, you need to have your equation in terms of the node voltage. So that's why what I'm doing here is I want to substitute the value of Ix in terms of the node voltage. So that's why Ix equal to I3 equal to V1 minus V2 divided by 2. Okay. And then after that, we can substitute this equation into here. Right. So Ix we can substitute with V1 minus V2 divided by 2. Okay, and then after that we can further simplify this equation so that we have the same denominator here. Here I have 8, here also I want to have 8, so I can multiply this term with 2 divided by 2, so I can have 2v1 minus 2v3 divided by 8. Okay, here also I want to get 8, so I can further multiply it with 4 divided by 4. So 4 multiplied with 2 is 8v1 minus 8v2 divided by 8. Okay, and then we can cancel this 8. Alright, and then after that we can further simplify it. So here I have 2v1 minus 8vv become negative 6vv plus, for v2 we have 1 minus 1 plus 8 will be equal to 9v2. So here I have negative v3, negative 2v3. So finally I have negative 3v3 here. So this is considered as equation number 3. And then next, we can just rewrite the equation in terms of the matrix form. So you just refer to the previous slide. So this is equation 1, equation 2, and equation 3. You can rewrite this equation in terms of here. So here you have 3, negative 2, negative 1, 12. So that's why 3, negative 2, negative 1, 12. Okay. Here 4, negative 7, 1, and 0. 4, negative 7, 1, and 0. So here you have negative 6, 9, negative 3, and 0. Negative 6, 9, negative 3, and 0. Okay. So, and then after that, you can solve the equation 1, equation 2, and equation 3 by using the calculator, or you can also use the function of matrix in your calculator to solve this matrix. So finally, you can get V1 will be equal to 4.8 volt, V2 is 2.4 volt, and V3 will be equal to negative 2.4 volt. So that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay, bye.